Hello and welcome once again to episode 89 of Code Completion. We're a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So we are back with more WWDC stuff. It will never end until we get through all of it. But this time, we figured we would go through what's new in Swift. And it turns out there's a lot of new things in Swift, which we mostly realized just by going through the list. So if you are interested, Apple has a changelog on the Swift repo on GitHub that just lists everything. So we're basically going to go through that and give you our supreme commentary on what you can ignore and what is useful. No, I'm just kidding. It's all useful, but there's a lot of nuance to a lot of the things. So what better time to discuss them? I don't think we're going to put a whole lot of concentration on each individual item. But there are some that are definitely more interesting than others. So yeah.
Yeah. So before we begin, like Dimitri said, in that changelog, it's very cool because it has links to every proposal. So if you it has a pretty good write-up of, generally some code examples and kind of walking through the changes. But I think we've talked about this before. If you want a larger discussion, you can actually go to the proposal itself and actually kind of see the conversation of, basically the process of getting whatever the proposal is into Swift and kind of get a little bit of a larger context, I suppose, for, the reasoning behind things or whatever. So,
yeah, that's the de facto documentation a lot of
pretty
time.
much, yeah.
Many times you might go check for code documentation. There's not really anything that explains why these things are here. And this becomes that documentation. So it's not ideal in that it's not part of the documentation, but it is documented. And as long as the proposals aren't changed over time, meaning new things aren't added to them, you're not out of date. So that's a good part of this whole system is you get some motivation into things that you previously would never have had motivated reasoning written down for other frameworks like SwiftUI or other internal frameworks.
Right. It's nice that it's all out in the open.
Mm-hmm.
Okay, so let's begin. I'll start with the first one, and immediately I'm going to ask Dimitri a question because I don't understand why it exists.
Excellent.
So it is opaque types expressed with some view, for example, can now be used in structural positions within a result type, including having multiple opaque types in the same result. So in the example, it has a function that returns a dictionary where the key is some hashable and the value is some codable. And my first thought is, why do we need that there never mind. I think I just answered my own question. You couldn't put just the protocol hashable and codable there, right? It would yell at you for just having those the protocols themselves as the values.
Yeah, so it's worth talking a tiny bit about protocols, just so that way we can contextualize a ton of these proposals. Protocols are kind of not optimal in Swift. So Swift likes to leverage the compiler to figure out exactly what type should be where, and then it doesn't have to necessarily encode type information along with that type. So, for instance, even though int is a high-level type in Swift, it still only takes up 4 bytes. It doesn't need to take up additional storage and memory to say, hey, I'm an int, here's my data. And then if you have an array of these, it's, hey, I'm an int, here's my data. Hey, I'm an int, here's my data. Hey, I'm an int, here's my data. None of that information needs to be encoded. In fact, the array doesn't even need to be encoded as being an array of ints. It can just be an array of 4-byte data. And the code all knows what to do with this. So it can skip over a lot of these checks hey, is this an int at index 43? And it can just go ahead and assume it is because the compiler did double checking first. Now, protocols get in the way because they can be used in two different ways. You can use them as generics, which basically uses exactly what I said. It says, hey, this function takes a type that is a protocol, but because it is a generic function, it can go ahead and be assumed to be specialized to that type that ends up being used. And what this means is that the compiler can basically say, hey, it looks like in this certain scenario, you're using this function with its types as ints. So we're just going to bake that in. So you're going to get a function that's as if it were written for ints rather than one that's written for anything. So that's where protocols can be used. The other place protocols can be used is if you have a generic interface that you want multiple types to be able to implement, and then you want to store that somewhere as a property, for instance. In that scenario, something completely different happens. We now need to encode at runtime what the type is and how to work with it. If it's a struct, if it's a class, all of that needs to kind of be encoded, so that way at runtime, when you do something with that property that's a type of protocol, we can go ahead and do something. So that's what's called a boxed type. And these boxed types, they're not exactly efficient because we have to now do multiple hops around, just like we were doing with Objective-C. So it's not less efficient than Objective-C, but it is less efficient than having a specialized type right from the get-go, because all that can live on the stack and be super efficient. So we are kind of moving away from a world where both of these uses of protocols can be ambiguous. And instead, we're moving towards a world where it's very intentional which one is being used. So you either use some protocol for the more generic case, or you use any protocol for the boxed type. And I think in Swift 6, the discussion is leaning towards moving away from the unqualified protocol name being a sum or an any type, which is currently it is, towards a sum type. So if you don't put anything before the protocol, that's going to assume that it is the sum type. So you're never accidentally introducing performance regressions just by using protocols without being truly aware of it.
Okay. That's interesting.
Does that make sense?
Yeah, it does. That's cool.
So in the context of this, where we have that sum, that means that we are at compile time saying, hey, it's going to be a consistent, the same type. It's just all you know from the caller's point of view is that it's a hashable type. That's the difference.
Gotcha. Okay, cool. That makes sense. Yeah. Okay.
10 minutes later.
Yeah, no, it's good though. I mean, there's so much more depth, and as I was running through all of these things that are added to Swift 5.7, I just was thinking, there's always that argument from people that Swift is so much more complex than Objective-C, and it seems like every time there's a new version of Swift, I'm like, yep, that makes more sense. That makes more sense. A lot of just, I don't know how to explain it. It just seems very... this is all great because it's all ease of use things, and it's making things that were impossible possible, where the compiler just wouldn't let you. But it is definitely adding, levels of complexity every time that we do it. So I get that argument, where before, when I was less versed in actually really both Swift and Objective-C, I was like, no, Swift is definitely easier. But as you get into these lower level things, it's like, no, not really. If you want to master it, then no, definitely not.
Well, that's what a lot of these changes aim to fix about the language. Is most of the difficulties people have with Swift are with generics and protocols, because they are kind of overloaded on top of each other, and you have these mixed identities that are named the same thing but are very different under the hood. So by giving a qualification, a name to each of these, it could definitely help people better understand what's going on. And if people better understand something, then it's less complicated as a result, right?
That makes sense.
So yeah, along with a lot of these changes, we now get warnings and help along the way, basically telling us that a lot of protocol conformances that we just thought we could take for granted are no longer actually as like foolproof as we thought. And the system will now go ahead and tell you, hey, this might not work the way you think it works. And people might complain and saying, hey, Swift 5.7 made things more complicated because now I have all these warnings. You were using it incorrectly up until that point. So that's what it's warning you about. So definitely open up your project in Xcode 14 and give a lot of these warnings, I guess, a go, just to kind of see like what kind of assumptions you're making are just flat out wrong, and fix them along the way, because a lot of them will work with Xcode 13. So do double check, but that can help you have more correct code with less headache and hair pulling later when you realize that there's actually a bug with something that you didn't think would be a bug.
Mm-hmm. Opaque types can now be used in the parameters of functions and subscripts when they provide a shorthand syntax for the introduction of the generic parameter. So I think this is one of them. I could be wrong. Again, it's a blur. There's so many of these things that have to do with generics and stuff, but it seems like a fair amount of these generic proposals that involve generics are making I think mostly functions, maybe classes or types as well, a little bit more easy to read, where there are like, you don't have to put like type constraints like the where clause in an extension or something. Kind of cleans things up. So in this case, it makes it so that you don't actually have to use the angle bracket syntax to specify, like in this case, it's talking about views, the Swift UI views. And so it's like v1 of type view, comma, v2 of type view in angle brackets. And instead, you can just put v1 as the argument name, and then some view. And you don't even have to deal with sort of generics in the sense of, making your own generic types, I suppose.
Mm-hmm. Yeah, and that cleans up, once again, like a lot of everyone's ability to write generic code, because again, it's intimidating. It's like, do I need a where? As soon as you start questioning yourself, do I need a where in Swift? It's like, well, how does where work? It's not really documented anywhere. You just got to know and see it by example, and flunder your way through. I'm forgetting the word. Flounder your way through. Yeah, like a fish out of water.
Yes.
That is me right now. The English language that I am native in. It makes it a lot easier to write many of these functions, because you don't need to remember the generic syntax for things anymore. You just need to know that, hey, sum is a specific but unmentioned protocol, like type that conforms to that protocol, and any is a boxed version of that type where it can truly be anything. So sum really makes that more clear, and we've been using it in Swift UI this whole time. Whenever you return some view, you know that anything in the body has to return the same type of view. That's what that sum means. So this really goes from the other point of view. So whoever's calling it doesn't need to guarantee very much. It just has to say like, hey, I'm always going to call you with the same view. But whoever's implementing the function can basically not care about that and just use it, because all they care about is it is a view. Mm-hmm. The next one is called distributed actor isolation. So this one is really, really cool. And basically harpens back to what I think Next Step had as a basic ability to have objects live on different machines. So you could basically say, hey, this is a distributed object, and it doesn't, all I have on my computer is the metadata of that object. But if I wanted to ask anything of it, a property, or for it to do something, all I would be doing is sending a message to a different machine, and that other machine will go ahead and do the work. So this was a very interesting way of having distributed computing, meaning you don't have to have a server necessarily. You can just do peer-to-peer, And you don't have to have an API necessarily for those things to communicate. All you have to do is imagine that computer over there is just a different core on your computer over here. And then you can go ahead and use everything as if it were local, just separate, which is what we're kind of used to doing whenever we're doing parallel programming and stuff like that. So distributed actors take that notion to Swift, but bring it in via not only a type safe way, but potentially a execution context safe way. Meaning, since an actor is like an isolated unit, it's an atomic thing that only operates on itself, a distributed actor is one of those actors just somewhere else. So the asynchronous nature of Swift really lends itself very well to this kind of notion where you can ask an actor to do something, and if that actor's on a different core, that's fine. If it's on a different machine, that's also fine. That's what the distributed part means, basically. So what landed in Swift is just the narrowly being able to prefix actors with this distributed keyword. And you can also mark functions as distributed, meaning there are some functions that can actually run locally, and there are some that will need to fetch data or communicate to a different machine or computer to do, and that's where you put the distributed in. There's a separate proposal for the actual runtime and all that, and that's like still in the works. So it's just the baby steps of getting this going. And once we have it, the promise is that you can just pick a library, and that library will go ahead and give you all the functionality of connecting your two machines, and then all you have to do for your code is just write your code with actors, and you'll be able to communicate between two machines. The WWDC session was using a tic-tac-toe game as an example of this, but it's not limited to games. Anything that you have to have two computers communicate, whether that is a server and a client or a peer-to-peer client, all of that becomes possible and very straightforward with actors. So if you can build out a system with actors, the only change you need to make is add distributed to that and have a communication mechanism where it actually can talk to another server. And it seems like the authors for this proposal are already writing a few reference implementations for that communication aspect. Like, you can write your own, or you can use one of these, and that will go ahead and get you set up, because Apple can't make assumptions about how you actually want to communicate with your servers, which Objective-C did make assumptions. It said, oh, well, it's happening like this. And then if you didn't want it to happen like that, you can write your own, but it was like way complicated. So, and not documented. So this is an improvement there.
Nice. Yeah, that's cool. I think for me, from my limited understanding of this, is it's cool that, if it's like local, then it just, it's just awaiting, it's just async. So, it could happen very quickly. Or if it needs to go to a server, to your code, there's no difference really. So just kind of all behind the scenes, or done behind the scenes. So that's cool.
Yep.
All right, the next one, top-level scripts support asynchronous calls. So I didn't know this was a thing, but like if you had like the main .swift and you were trying to call something asynchronous in main, it wouldn't work, or something like that. I was reading
you would have to make a task
on it. Yeah, so I think it's just allowing that kind of at the highest level, allowing async await. Am I missing anything?
No, that's basically it. And the way this bit me personally many times is whenever I try to mess around with async await in a playground, which is a place that you might want to learn about these new things. And I'm like, why can't I? Oh, I just gotta make a task, and then your whole Swift file is a task. This gets rid of that, and that's nice.
Nice, that's cool. Another one that is, I think, really cool is explicitly allowing you to not use something, or let's see, how would I say this? I'll just read it. It's now possible to make declarations unavailable from use in asynchronous context with the @unavailable no async attribute. So if you specifically want to make something not available in an async context, then you can just mark it and it will not allow you. Paul Hudson in his kind of write-up had a good point where this is a good first step, but it doesn't actually completely protect you. Like you can kind of get around it by, I can't remember exactly how I did it, but you sort of obfuscate it like one or two layers, and then it is actually still possible to kind of asynchronously call this function, even if you've marked it as no async. But it does disallow sort of a direct call, I suppose, if that makes sense.
Mm-hmm. So. It's a compiler helping hand for documentation that says this is not thread safe. Mm-hmm. So you can wrap it in a call, but it's still gonna blow up in your face. Right. So yeah, be careful there.
This is a cool one. I think. Well, we in our Slack group talked about this a while ago, where it's now possible to unwrap optional variables with sort of a new shorthand syntax where 99% of the time we're just unwrapping something and saying like if let foo equals foo with the new variable name as the same as the thing you're trying to unwrap. So now it's just if let foo and you don't have to do the equals whatever. So that's nice, just shorthand. But at first I was like, this feels weird. But now that I look at it, I'm like, that is actually really nice. I haven't used it in any code, of course. I haven't even opened Xcode 14. But nice. I'll ask you, I'm sure you know, does it also work with guardlet?
Yep. It works in any let context, or like conditional let context. And yeah, it's something that the community has been very divided upon for the past, like, basically since the if let syntax was introduced in Swift 1. So the maintainers of Swift have for a long time said, we don't think this is a good thing to do, but I don't know how many years in are we, 5, 6, 7 years in. It's definitely worth considering now that even after all this time, it's still something that people feel should just be part of the language, and it has kind of warranted itself some syntactic sugar to make it a little easier to type.
Yeah, and there's nothing, I mean, if you don't want to use this, you can still write it out. I'm sure it's not going to not compile for you, so.
But linters will notoriously erase all the duplicate stuff, and that's like one thing I don't like about linters is because they will kind of just rewrite code whenever someone changes a rule. That makes a mess out of any Git history that kind of tells you like who did what where. And you can like say, oh, this commit should be ignored by the Git blame or Git authors view, and then it'll just skip to the next one. But like no one does that, so this like that should be mandatory like reading for people who want to add linters is like, oh, you all should also like add these things, otherwise the linter will just kind of cause chaos with history, and that's like the one useful thing about Git for most people is that history. So yeah, I'm I'm a little divided on like what's gonna happen because of this rule.
Oh, yeah, this is interesting, and I wanted to see if I understand this right. So it has to do with closures. It's now possible to infer parameter and result types from the body of a multi-statement closure. The distinction between single and multi-statement closures has been removed. So it was in a fairly recent version of Swift, as I understand it, where if you opened up a closure with, or you hit return on a closure function that has multiple closures, it would like open them both. So is this saying it's getting rid of that kind of dual functionality, or am I?
No, this is completely different. So you'll know this from Vapor and server-side Swift programming, where if you have like chained futures, sometimes you need to specify what the return type is.
Oh, okay.
Yeah. And this is getting rid of that. That said, sweet. You don't use those anymore, so it's less of a raring thing. But for simple things like maps, where you had something more complex, where it wasn't clear what the result type could be, like if you added a guard, like that's that. You now need to specify a return type. So this will basically verify that, hey, all your return types are the same, and if they are, this is the type that your closure is returning. So that vastly simplifies things.
So just better, I guess, type inference. in general for those closures. Okay, cool. That's awesome. Okay, yeah, more generic stuff. So it's now possible to use a default value expression with the generic parameter type to default the argument and its type. So this is cool where if you have a function, so in this one it has a function called compute. It's got a generic type of C that is of type collection or conforming to collection. And the values is an array of C. It is a collection. So in this example, it has a default value of an array of 0, 1, and 2 as integers. So you can just give it some default value, even though, that's sort of an explicit type, as I understand it. And it's just cool with that, even though you're giving a default value to a parameter that is a generic, if that makes sense.
Yeah, in the past you would have had to have your generic function and then a extension that defined the version with the default value that called the generic function. So this simplifies all of that and allows you to do it in one go. Again, cleaning up the whole mess that is generics and doing that well. Because you might think, I'm starting to get the hang of these generics, and then as soon as you start wanting to use default values, it's yelling in your face because it doesn't know what to do with them. But now it can use the default value version, which is really just a different function under the hood. We know this from Objective C. When you wanted to have default stuff for your arguments, you just made a different function without that argument, and that's your default version. So this does the same thing from the compiler's point of view, but it synthesizes all that code for you, which is really nice.
All right, next one. It's now possible to call a generic function with the value of protocol type in places that would previously fail because any types do not conform to their protocols. I don't really understand this if I'm honest.
So this one is really, really cool because it allows existential types, which are protocols with associated types, to be used in many, many more contexts. So in the past, if you wanted to have a collection of ints, but you didn't really care what type of collection it was, it could have been a sequence or it could have been an array or a set, does not really matter from your point of view. You just want to iterate over it, right? Mm-hmm. You could not really store this anywhere. You would have had to use a special type called an any collection of ints, and that any collection is a struct, so that you can use. But if you wanted to make an any collection, if you look at the code for it, this is a crazy piece of code. You have a struct that has an internal box type, which is a class, and that internal box type has a subclass which is specialized to an array or a set or something. It doesn't really matter, but because it's a subclass of a class, you can hide that generic conformance inside of the box type, and no one would be any wiser because that is all encoded at runtime. So you're just using the superclass, which does not care, re-implements all the methods. So you end up with a ton of boilerplate to make something called a type erased version of your existential protocol. Okay. This gets rid of almost all of that by just adding the any keyword. That is nice. What is so amazing about this. So highly recommend.
So it's now possible to use the withMemoryRebound with a generic method on raw memory and their mutable counterparts. So
fascinating.
Cool. I don't ever touch memory or pointers very much, so I had no idea when this would be useful or anything. So,
well, it's when you're dealing with memories and pointers. It used to be more boilerplate, and now it's less boilerplate. So, yay! Yeah. Okay. I have not written any of code that uses this, and I'm afraid of calling any C function from Swift because there's a whole bunch of other gotchas check error num and check it quick, because if you don't check it quick, it might get overridden by a stray release or something. And it's super fraught with all sorts of craziness. So if you're using very low level stuff that deals with memory and unsafe keywords, then this will make your life easier. If you don't use any of that stuff, then this will be inconsequential to your day-to-day productivity.
Sweet. All right.
Yeah.
The next one also has to do with pointers. So there's new functionality for pointer arithmetic on unsafe raw pointer and unsafe mutable raw pointer. Adding functions to obtain a pointer advanced to the next or previous alignment boundary. And I am not sure what alignment boundaries are, so I have no clue.
Okay, so say you have a struct and there are 3 int properties in it, okay? Mm-hmm. So this struct takes 3 uint8 properties, okay? So they take 1 byte each. Yep. So this struct now has 3 bytes. If you have an array of these structs, you're going to have 3 bytes for the first struct, 3 bytes for the next struct, 3 bytes for the next struct. Okay, turns out this is super inefficient for computers to deal with because computers don't actually refer to like an exact point in memory. They refer to an exact point in memory by word. And a word meaning if it's a 32-bit processor, it jumps 32 bits at a time.
Oh.
If it's a 64-bit, it jumps 64 bits at a time. So it is possible to get at these unaligned entries, but you need to jump to an aligned part and then advance a little bit and like do some bit arithmetic. So that is inefficient. So what the compiler will do for you is with your 3-byte struct, it can do one of 2 things. It might keep it as 3 bytes and say like, hey, this is how you're going to access it. Or it might do something very different in that it will align each of your bytes, your uint8s, which take 1 byte, to aligned areas in memory. So now your struct, instead of taking up 3 bytes in memory, it now takes up potentially 12 bytes in memory, like 4 bytes. Or much worse, it could take 8 bytes each, so it's 24 bytes total, because it wants to align things to 64 bits and so forth. So where this comes to bite you is if you have a stream of data from the network, for instance, that is unaligned because it's compressed as best as possible. But if you convert that to like structs, that might become aligned just by nature of you building those structs and storing them in an array. So this allows you to jump through those alignment boundaries very efficiently. If you're in C and you like use indexes on your array, that will do that automatically. Whereas if you do pointer arithmetic with your array, that will not do it automatically. So that's basically the difference. So this gives Swift a lot of aligned pointer arithmetic. And it also, I think in the very next proposal, gives you unaligned pointer arithmetic, if that makes sense. So it's very explicit what you're trying to do. Much like dealing with, if you've ever dealt with network data, you have big endian data and little endian data. And in most languages, it's unspecified what you're dealing with, which actually adds bugs because no one is paying attention to what endianness anything is. So if you want to store anything to disk, or if you want to send it over the network, you want to transform your integers into big endian variants before you save them or before you send them. And that will kind of be very explicit because you chose to do it in big endian, which means that everyone knows you're doing it in big endian. So you can always do that conversion back to little endian when you consume the data. So kind of like that, this is also like being very explicit in your code. That's basically it.
Maybe I'm not getting this right. When you said it could potentially increase to like 24 bytes or whatever. Is it sort of like, are you increasing memory usage at the sort of benefit of increased performance, or is it like you could interleave things within those? Yeah, I don't know.
Yeah, it might be garbage data. It might be zeros. It really doesn't matter because that memory is never accessed. But you are increasing performance at the cost of increased memory. Yeah, that's absolutely it.
Okay. All right. That makes a little more sense.
So that's often why when you want to store things efficiently, you have an array of uint8s that will pack things. But if you have structs, that might pack things within the struct. But then if you have multiple structs side by side, that will not be packed because those will have to be on alignment boundaries. So that's where all of that comes in. It's kind of like thinking about bits, right? You can't have 3 bits. You have to have 8 bits, right? It's always aligned to a multiple of 8. So this is similar on the level of bytes, how those bytes get aligned. That's the quick way of explaining it.
Okay, yeah, that makes sense. Oh yeah, so yeah, like Dimitri said, the next one is just allowing unaligned accesses of raw pointers and unsafe raw pointers and unsafe raw buffer pointers. So is that anything else to say about that?
No, it's just super explicit, and you don't need to be left guessing. Is this going to be aligned? Is this going to be unaligned if I do pointer arithmetic? So this allows you to not need to do pointer arithmetic, which is the whole point of memory safety. Gotcha. Anytime you're reading a pointer as if it were just a number and then just using that to access memory is super dangerous, because all sorts of things could go wrong. So it's still dangerous if you're using these unsafe types, but it's less dangerous because at least you know what's maybe going on rather than not knowing platform to platform, generation to generation, what can change.
Okay, cool. All right, the next one has to do with protocols again. Big surprise. Various protocols in the standard library now declare primary associated types. So, for example, sequence and collection declare a single primary associated type element. For example, this allows writing down the types some collection angle brackets int and any collection angle brackets int.
Yeah, so we mentioned this previously of why this is now possible. It's because we now have these box types which are given to us by the system. But that's not enough to describe what kind of collection it is. So we now need to have a way of specifying generics for a protocol, and this is basically what that is. So it allows you, instead of saying an array of ints, you can now say a collection of ints, and you don't care that it's an array. It can be an array, a set, anything that's a collection. And conveniently, all collections have an associated type. And if you have a protocol with associated types, you can now specify those associated types as, what did they call them? Lightweight, I'm forgetting what they call them. But it's like a primary associated type, basically. So you declare those in angle brackets, just like you would a generic type that you write yourself.
The next one is also with protocols. Protocols with primary associated types can now be used in existential types, enabling same type constraints on those associated types.
It might be useful to take these out of order. So there's another one that's a little higher up in this list, which I think they kind of just copy pasted all 4 of these as one block. But if we jump to Swift Evolution 0309, and this is unlock existentials for all protocols. This is kind of like the foundational step, and then everything kind of builds on that. So let's start with this one. But it allows any protocols with associated types or self requirements, and that's anytime you have specify self with a capital S. You can now use those with the any keyword. So the any keyword was previously just introduced for regular non-existential protocols, and now for the existential ones that have associated types, you can now also use the any keyword. So this allows you to skip that process of writing those boxed types that I was mentioning before, where you write a struct with a class and a subclass and a ton of boilerplate to link up all the functions between there. This still writes all of that, but it synthesizes this code for you, basically.
Gotcha. So if we go down one, protocols can now declare a list of one or more primary associated types, which enable writing same type requirements on those associated types using that angle bracket syntax. So is that just saying you can now actually use angle bracket syntax with those kind of generics?
Exactly. So with a protocol, you can now use angle bracket syntax in the type definition. Nice. And it allows you to say, hey, these are my primary associated types.
Cool. Okay, so now protocols with primary associated types can now be used in existential types, enabling same type constraints on those associated types.
Yeah.
Oh,
So
okay.
just linking it all up, basically.
Okay. Yeah.
One proposal at a time.
Okay. Yep. That makes
That's
sense.
why it made no sense that this was like listed out of order in the document. So that's why I flipped them all around. Sorry for the confusion.
No, you're good. I wasn't reading the notes, so that's my bad. Oh yeah, okay. So this is super cool. New types representing time and clocks were introduced. So this is super cool. It kind of just seems like almost a continuation of like calendar, where it was for like dates. We're just kind of going a little bit lower, where now we've got time. So the example that it gives is you've got like you want to sleep, and instead of like dealing with, I can't exactly remember what the type is. I think it's a C type, but you're dealing with like milliseconds, right? And now you
Nanoseconds.
Nanoseconds. So now you're dealing with the clock types, which you can do like dot milliseconds, you could do dot seconds. So it makes it a little bit easier for you to like reason about. You don't have to put like, 10 million for whatever that ends up being in seconds or whatever. So that's super cool.
Yeah, and I think that's the motivation to do it, right? Because if I say 10 million right now, how many seconds is that, Spencer? Can you say it off the top
I have
of
no
your head?
idea. No,
Exactly. So like no one knows how many nanoseconds are in a second. We are programmers. We are not mathematicians or physicists or any of that. We make UIs be pretty and go blink blink. So this is a very welcome addition where it basically types time. So you can say dot seconds to specify things, and that is nice. It also comes with 2 clocks, which I feel like we should at least mention to a tiny bit. So there is a continuous clock, which works like the clock on your wall, where it's the accurate time. And then there is also a suspending clock. And the suspending clock is cool because it's the amount of time since your computer turned on, and it will never decrease by definition. So if your computer sleeps for a little tiny bit, then it will like not notice that it slept. It's as if the computer was like on this whole time, or on, and then it just like blinked out of existence, blinked into existence, and is like still on. But it didn't notice how much time it was out of existence for. Whereas the continuous clock will either A, notice that, and it will say like, hey, 17 hours have passed, or if the time has changed by the user or by the system, then it will go ahead and say, hey, negative 17 hours have passed since the time was corrected. So you'll be able to see these two things without necessarily using date, which is kind of like an overloaded class or type that mentions both the time on the calendar and the time within the day. And if you use it to compare values, you might get different like results, because depending on if the computer slept, depending on if the computer's time was fixed in between, and things like that. So in times where you were using CA media current time, or whatever the core animation call is that gives you that exact thing as a nice number of seconds, you don't need to use that anymore. You can now use a suspending clock, and that will give you the same information.
Yeah, I was just going to mention, it's like there's like that CFD absolute time get current or something that I would always use to like measure performance and stuff. And the last thing that's in kind of this summary for the proposal, and I'm sure the clock classes have much more functionality, but there's just a measure method that is just a closure. You put your thing in there and it will give you how long something took. And that's so cool. Just that one thing was like, all right, sweet. Between that and the being able to just specify seconds or potentially hours or whatever you need, that's fantastic. So super cool addition there for sure. Anything else before we move on with that?
No, I mean, it's easy to write your own benchmark too, because with benchmarks you want to like calculate this multiple times. You just wrap a for loop around that and average your elapsed values. So yeah, awesome, really
good stuff. What's not really good, I'm just kidding, but not really, is, we talked about this last week, is we now have regular expression literals. There's, I think, maybe a few proposals kind of in general that have to do with the regular expressions, but There's just a new type that is regex with whatever your output is. So yeah, we talked about regular expressions. I don't think we need to give them any more
screen time.
The spotlight. Yep. Unless there's anything you want to add.
Well, I just want to go ahead and say that the part that's in the language so far is the regex type, and this has like the generic output that it understands. And there's different proposals for the other aspects of regex, which we can get to in like 5 minutes. So yeah, that's what's in and what's coming.
Cool. All right. So the last kind of big one that we have here, as far as I'm looking at the changelog, not Dimitri's notes. Yes. Okay. Is non-isolated async functions now always execute on the global concurrent pool. So calling a non-isolated async function from actor isolated code will leap the actor. And I'm sure Dimitri can expand on this a lot more, but my understanding of this is like it frees up the actor if it doesn't need to be run on the actor, if that makes sense. Like if you, I don't know.
Yeah. Long story short, mistakes were made. And the actor system was kind of like made in isolation from all the UI system that everyone actually uses. So as soon as people started using @main_actor, they were noticing, hey, the code I'm writing is not actually doing anything on any other queue. It's still running on the main actor, even though I awaited it. What's going on? So this kind of fixes that, because if you start a task on the main actor, it's not necessarily going to stay stuck to the main actor until you call into a separate actor. Any function that's marked with async can now execute on a concurrent queue, or pool as they call it, because it's not queues anymore. And it will switch immediately away from the main actor to let the main actor start doing UI stuff again, and not be burdened by the work that you've explicitly said you want to wait anyways. So it will still switch back to the main actor for anything that is @main_actored, but anything that isn't main actorized will be able to run on the concurrent queue now. Yeah, so it's a bit of cleanup from past mistakes.
All right. So then we've got a bunch that are in active review or coming real soon. And is this... You mentioned something like they're in Xcode, but not actually as a part of Swift itself. Is that right?
Kind of. So they're bundled in the version of Swift that comes with Xcode 14. They are still in active review, meaning they can change. They're very much beta. So everything we talked about so far is not beta. This is like Swift 5.7 proper. Yep. Like a new proposal might come in to change things last minute. Fine. But they haven't discussed at length, and this is what they're going to be. Anything active review can still change based on feedback, and Apple is essentially collecting feedback during the beta period to get these properly tuned, as you would for primetime, whatever that term is. Blah, blah.
Yeah. So one is a regular expression builder DSL. So
this one is awesome.
Yeah, I mean, I think the cool part about this for me is like, if I had to use regular expressions again, I think it would make things a little bit easier to understand. And that's kind of the big part there, where it's instead of just being like one gigantic gross string, it looks like, I mean, it's a DSL, right? So it looks a little bit more Swift UI-ish in the sense that you can expand things out and make it a little bit easier to understand, I suppose. So in the proposal itself, it has a pretty good example of, I don't think it has like what it would be if it was just as a string, but you can look at the regular expression and be like, oh yeah, I can kind of understand what's going on here, as opposed to being like, this is a garbled mess. I have no clue what this means.
Well, let me read it out and see if you can guess. In the example, we are capturing 0 or more words with a period at the end of them, followed by a word. So we're capturing that whole thing. Then we have an @ symbol, And now we are capturing a word followed by one or more period and word combos. What could that be? Well, like if you were to write that out literally, it's just an email address. As simple as that. There's no slashes and D's and brackets and dots that don't mean dots.
Yeah.
Like regex, what were you thinking? Anyways, this is like clearly spelled out. It's type checked. You have a email pattern that now has 3 like things that it returns, which are substrings, which you explicitly captured, which is awesome. And yeah, like I am all for these new regex builders. I don't think they should have the name regex attached to them. They should just be like pattern builders or something cool, because they are way better than regex. I'm actually slightly jealous of this, because I built something similar for async sequences to be able to consume a sequence of bytes. And this looks way nicer than what I put together. But I'm not sure what I put together is something that can like actually be rebuilt with something like this. So it is something to consider. But yeah, this is like way nicer than regexes. And yeah, you should never write a regex again with this. Like this would instantly make everything more understandable for everyone else. Even if you understand regexes, no one else will, and you might forget. So yeah, don't use them.
Yeah. Yep. And then the next one is just the actual literals. You could just write them as a literal instead. So I'd say
these are
ignore
the
that
bad
proposal. Yeah, ignore that proposal and just use the builder.
So one thing with the literals, it's actually quite harder than you might think to just introduce new literals to the language, because slashes are used everywhere, right? You can divide things, you can have comments. Is a comment a regex literal? Who knows? You'll notice the languages with regex don't necessarily use / as their comment type. They use pound or something.
Right.
So that introduces some weirdness with the language and some cleanup that might be necessary. So Swift 6, which is the language breaking or the syntax breaking language update that will come in the near 10 years, whenever they decide to ship it. That one will basically like have regexes built in and robust support for them in terms of using the / syntax. But up until then, all sorts of code and comments might break as a result of not necessarily considering what a / might do, or a / followed by stuff and then another /. So this is something that the community has kind of discussed, and there is a new option called enable bear /regex, which will enable it in Swift 5.7, but it will not enable it by default, which means that your code, it gives you a way of checking first before we migrate to Swift 6 if your code is problematic, so that we can fix it now and have less of a hard time when Swift 6 launches. Does that make sense?
Yeah.
So this is,
but still don't use them.
Well, yeah, this is how this proposal might impact you despite not using. That's the the long story short there.
Interesting to think about, though. I mean, we haven't had like a big breaking change since like Swift 3. It seems like.
Yeah, Swift 4 basically promised it would try its best not to break things. And Swift 5 like delivered on that promise, I would say. Maybe?
Yeah,
I don't know.
So.
It's been a while. I feel like we've had a new 2-point releases of Swift a year for Swift 5, right? Like they come in pairs. You have one early on and you have one mid-cycle that just like with Xcode 14.2 would bring a new version of Swift, for instance. So yeah, they've been doing a good job at not breaking code, and the recent new versions of Swift have only added warnings for things that you've been doing wrong this whole time anyways. So that's very welcome.
Yeah, the next one I don't understand. Regex powered string processing algorithms.
Yay.
I don't know what that means, and I don't care.
So a lot of regular expressions require the ability to look ahead in a collection. But a lot of collections don't want to be looked ahead. They kind of just give you a static view, not a static view, a dynamic view into their space. But they make no guarantees that view is going to be unchanging or anything. Like if you go through it once, like you're expected to just go through it once and not necessarily like look back and refetch things. So this adds a whole bunch of missing pieces to collection types and string to be able to use regular expressions effectively. They are like general building blocks that can be used for all sorts of other things, but regular expressions are the natural use case for many of them. And one such example is being able to look ahead of your collection before you consume the collection, if that makes any sense.
Yeah, no, it does. My question is, who is using all of these regular expressions?
Well, clearly lots of people with CSV files. Yeah. That said, Apple has like a cool framework that's like macOS only. Is it macOS only? I don't know. It's on their platforms. It's not part of the Swift open source thing. Called Tabular Data or something, and it allows you to consume like CSV files and stuff like that. So yeah, that's a cool framework that you should check out if you're thinking about using regular expressions. Just don't and use that.
Basically, we're trying so hard to like divert everyone away from regular expressions. I love it.
Honestly, they're not that bad as long as you use the builder DSL. And it looks like the literals, like you can print them to the console and it will give you the builder DSL or something. So like that was part of Apple's grand plan to move everyone away from regular expressions as well. So yeah, I'm all for that.
Yeah, that's cool that they did that. I just remember sitting there. It's like regex101.com or something, and I would just
I always
have the string, and I would just like have to go through their like docs that are on that page and just mess around until I got the thing. I was like, I still don't understand this, and I've spent hours and hours and hours on this. So I just like have just this deep rooted abhorrence to regular expressions. So luckily I haven't had to use them.
Not to mention it's like incomplete too. Like the email one that we gave in as an example is wrong. Like don't use that to check for emails because there are emails that just don't follow that at all. That they have quotes and spaces and all sorts of things. Like those are valid emails and your service will basically poo-poo that person's email. So like a regular expression that understands email does not exist. Like a surprising like truth that might shock you all. But if you go to any Stack Overflow answer, if it's a good answer, it will say, hey, there's no regex that will satisfy any email because emails are much more complex than you think. Don't necessarily think that regexes are the be-all, end-all of everything.
Yeah.
Away from regexes.
Finally. Distributed actor runtime. With the recent introduction of actors to the language, Swift gained powerful and foundational building blocks for expressing thread-safe concurrent programs. In distributed actor isolation, we took it a step further, guaranteeing complete isolation of state with distributed actor isolation and setting the stage for distributed method calls to be performed across processes and node boundaries. Yep. So is this just sort of the building blocks for allowing the distributed keyword? Or is there something else along with this?
So the distributed keyword is part of the language. There is a protocol that you have to implement to kind of get that going. And that protocol, I believe, is part of this proposal because they're not sure of like all the steps that are involved to actually get this working. So what Apple has been doing is they've been building an open source package called the Swift Distributed Actors Library, which is a reference implementation of a peer-to-peer cluster for distributed actors. So this is a high-performance library built on top of Swift Neo that will connect a cluster of servers, basically, so that way they can all communicate together. And they can all communicate instantly with message callbacks and things like that. So this is a reference implementation, but also a real in-use, in production implementation. They didn't specify where they're using it, but they are using it because that is how they're learning about what parts are needed to make this system work. So that's why this part of the protocol is still in review, is because that work is still ongoing. And but it's still like it is actually being used, so it's not like completely alpha code. It's very much in the beta stage of things, and it will likely be finished by the end of the beta period for Xcode. So definitely give it a look. If you want to build something, you can definitely build it on top of this. You just have to follow along with any API changes that happen last minute, but with packages you can lock to a version like without any issue. So
Right.
as with most things in the beta period, everything changes, but it changes based on your feedback. So if you want to kind of go and give this a try and you have actual feedback, there are actual like Slack groups with the authors of this protocol there, where if you bring up something that seems like missing or truly broken, like they will highly consider it during this time period and probably afterwards, since it is an open source project. So this is like the best of Apple building out in the open. So definitely take advantage of it.
Yeah, sweet. This next one's pretty cool, and probably going to have to, definitely going to have to bounce off Dimitri to make sure I understand this well. But in Paul Hudson's kind of write-up of this, he explained that, like in Swift UI, for example, you can't have more than 10 views in a result builder. And it looked like, and I had just woken up when I had read this, so I could be wrong. But it looked like what they did was they literally implemented methods for taking in a single result, and then 2, then 3, and all the way up to 10 results. And that's why it kind of just explicitly stops at 10 results for a result builder. But it seems like, is that right so far? Is that they just wrote 10 methods?
Yep, and that's why it's limited to 10, because they stopped there. They could continue, but they didn't really want to. I guess with the new Swift package plugins, you can have it just synthesize 100. That will probably be atrocious for compile times, but it can be done. Yeah.
Gotcha. So in this, so this is the actual new proposal here, is the ability to, there's a buildPartialBlock for result builders. So it seems like, as far as I understand, it's just 2 results, but you sort of combine those into one sort of result. And so in theory, you could have as many results in, as you want, if that makes sense. I don't think I explained that well.
And so I think the example they give is it works like reduce. So you take 2 things and you reduce them into one. Now that one thing is then passed into reduce again, and you take that thing plus a new thing, and then you reduce it into one. And then you pass it back into it again, and now you have that thing with 3 things and one thing, and you combine it back into one. So you do this piecemeal, and because it's piecemeal, it can be done for any number of arguments. It's essentially like a loop. It's consuming it one by one, and then adding it to a list, an ever-growing list of things. And this works because we have those generic protocols now where you have like a some view, and that can be any view really. It doesn't really matter. So it's just combining some view with some view. And even though that first view is growing one view at a time into an ever larger tuple, or tuple of tuples of tuples of tuples, because it's always like a group of one larger.
Yeah.
Things are much better. Now, I think Paul Hudson, I was about to call him Swift Hudson. Paul Hudson, I think gave the example of if this were used in Swift UI, it would like make things way better. In fact, it is being used in the Regex builder DSL, so it's not necessarily being used in Swift UI yet. But in Regex's, it is, and that's like the use case that they're using to build this out. So that's really cool.
So in theory, I think Paul Hudson said, like, now in theory, Swift UI could have more than 10 results at once.
Yeah, so you no longer have to group things. If they chose to
implement it. Yeah. Cool.
This reminds me, actually, for the math nerds out there, there's a theory of math called set theory, and this basically defines all integers as unions of sets. So like you have the empty set, which is nothing. But if you have a set of the empty set, that's 0. 0 is the set of the empty set. Now 1 is the set of 0 and the empty set. So it's a set of a set and nothing. And then 2 is the set of 1 and the empty set. And you slowly build them one by one like this. But you have to remember that every integer is itself a set. So you can like expand it however big you want. And it's a naturally progressing sequence. And this very much reminds me of that, because this is exactly what you end up with. You have a tuple of a tuple of a tuple, like all the way down, and that's how you kind of represent all your views. So, yeah, just wanted to throw that there. I failed my math classes, by the way.
Yeah,
but,
I also did as well.
They were very fascinating, nonetheless.
Yeah, I dropped out of my math class my senior year, because I didn't need the credit, so I just dropped the class, and it was awesome. Anyway, I kind of regret that now, but that's a story for a different day.
You missed out on all the set theory, Spencer. This would have made so much sense to you.
I know, I would have been just reveling in set theory with you there, but alas. Okay, this is super cool. Swift snippets. So it says this proposal defines a convention for writing a new form of sample code called snippets. They're short single file examples that can build and run from within a Swift package with access to other code within that package. So I think that in the example, they were just writing like basically like, like documentation, just comment or, triple line documentation above like a function, but you can write some code and it has a couple keywords in the comments themselves. But I think you could just pull it up and actually run that in kind of this, it's almost like, I guess the way that I was thinking of it, and you correct me if I'm wrong, is like it's like a playground within documentation, basically.
So I'm not sure if I'm not sure if you are right or wrong. The way I conceptualized it, which might be right or wrong, I have no clue, is that the compiler can verify what you write and make sure it doesn't get out of date. That's what I understood this as.
Okay.
It being, I don't know if you can actually run them, or if it would make sense to run them at all.
Okay.
I mean, maybe you can just to verify that the code you're writing for your documentation makes sense, because just because it compiles does not mean it makes sense. So there's always that. I guess there are print statements, so maybe those print statements do run.
Oh yeah, maybe you're right. I don't know. Cool, regardless. Sorry.
Title of the episode, cool regardless.
Yeah.
So yeah, it says here that it requires an enable experimental snippet support feature flag to actually turn it on in the doc.c plugin. So it's not part of Swift per se, but it's part of this like ancillary ecosystem of Swift. And I think it's really neat that there's more of this, because we should all be writing more documentation, and this makes it easier to write more documentation. Documentation is like generics. It's like so complicated, no one wants to deal with it, therefore no one does it, and no one understands how to do it well, because there's no practice like doing it, right?
And then I think the last one that we have is opaque result types with limited availability.
Fascinating.
So is this just marking something with like add available, like in some opaque type, or? Yeah,
so it basically allows you to change the value returned from a sum based on the availability. So if the availability says a new version of the OS has a new type, you can return that new type as long as it conforms to whatever protocol you're returning with sum, right? But if you're on an older version of the OS, you can return a different type. Now, this is a bit confusing to me, because it basically breaks that guarantee that's at compile time that we want to make sure that the types are well defined, which means that the compiler can optimize that type baked in directly, right? But if we have availability marks, then this result becomes dynamic, then it might not be as clear how to bake it in, because now there could be two different types, right? Thinking back to an array of structs, if you have a struct that takes up 2 bytes of memory versus a struct that takes up 10 bytes of memory, you're going to have a very different array at the end of the day, depending on how it's packed, as we mentioned. So that is something that the compiler usually would have taken care of for you. Now, with these availability checks, which are runtime checks, I'm not too sure how this all works together. It might just be that the compiler will kind of bring the add availability up a level. So that way at the call site, that availability actually now gets used directly to switch between two different implementations. And maybe that's how it deals with it. Maybe it just boxes things, and this is boxing things unnecessarily without you necessarily knowing that it's happening. So I'm not sure if sum is the right way to go about that, but it really depends on the implementation if the compiler can guarantee things or not. If it can, then sum is the right keyword to use. If it can't, I think maybe any should be the right keyword. That said, we are past the review period for actually no, it's still an active review. So if you have thoughts, I'm sure much smarter people have mentioned the things I have mentioned and whether they are important or not. So I guess check those review like posts in the Swift forums for more on that. But yeah, those are my quick thoughts on that proposal. So this week's episode of Code Completion is brought to you by Huuungry. Huuungry, that's Hungry with 3 U's, is the iPad, iPhone, and Apple Watch app you turn to when you really want to eat, but are blinded by the multitude of choices available to you and your insatiable hunger. Huuungry isn't just here to help you discover new restaurants or flavors. No, it has a much more humble purpose. You tell it all about your favorite restaurants, and it will deploy its cryptographically advanced random number generator, invoked by shaking your phone in frustration, to make the decision of what to eat for you. Stuck at home in quarantine and sick of ordering pizza? Use Huuungry. Did Huuungry just suggest pizza again? Don't fret, as other options for another cuisine, a cheaper restaurant, or even something closer are just a button away. Huuungry also comes with a collection of fun animated iMessage stickers so you can share your hunger with others. Thanks again to Huuungry for sponsoring our show. Search for Huuungry, that's Huuungry, on the App Store today to give it a try. So with all that out of the way, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at Code Completion to know when new episodes go live, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis. That's SpencerCurtis on Twitter for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buñol. That's DimitRiBounIol. And we'll see you all next week.
Bye.
Bye. So I have a short story to tell. And
excellent.
I am very sore as a result of my short stories, so I will tell this in paces. But at my home, whenever we want to go anywhere, we get in the car, we pull out our phone, and we try to search for the place that we want to go to get directions to it, just so that way we know if like roads are closed or anything, or we just have the map open. Things just stall because there is poor internet around like our driveway. So I wanted a way to like have better internet there. Additionally, like when you pull out of a driveway, oftentimes if cars are parked on the road, you can't see anything unless you're in like a Super Mondo F1 Cruiser or whatever they call those giant pickup trucks with like suspension and stuff. We do not have one of those. As you might guess, we have a little tiny car. And a little tiny car driving up to a street with those vehicles means you can't see anything no matter what. So we wanted to put one of those Logitech circle views. I forget what they're called. Mm-hmm. Yeah, yep. we covered them anyways. We wanted to put one on top of our garage so that way you can kind of see the street for us. And then we can use the home app on our phones to kind of like get a little sneak peek at what's coming, at least so that way we can see past the car that's immediately there, because otherwise we're just kind of sneaking in the blind, and that's not ideal if someone's not paying attention on the road because they drive fast. So we wanted to have just like an extra layer of maybe it's safe. Not that we should rely on the camera, because things can always be like latent and stuff like that, but it's better than nothing, which is the bar that I was setting for this. Now, that said, we have like zero Wi-Fi out in the driveway. Actually, we have just enough Wi-Fi to not be able to connect, or not be able to actually connect to anything, but it's like your Wi-Fi looks great, so it's not actually disconnecting us either, and that auto like shift to cellular does not work amazing. So yes, this is a problem there. And now for Wi-Fi in my house, we use a bunch of Airport Extremes, which I have one right there. And these have been made by Apple. They support Wi-Fi AC, which is, I think, called Wi-Fi 5 now. Things are changing rapidly. But Apple has stopped making them, like, I think 10 years ago, like a long time ago. And they continue to work just fine, but I only had so many and I needed a new one. So I went to our good friend eBay, and I like did the bidding process for the very first time. I'm like, okay, if there's an airport that someone's getting rid of, it's because they just replaced it with something else, not because it died, because these things don't die. Like the time capsules, they do die, but they're easy to take apart, and the part that dies is usually the fan that's at the bottom of it. Like the grease kind of gets like ancient, and then the fan does not spin anymore, and that's how they quote unquote die. So all you have to do is take it apart, get a really long hex screwdriver, you can open it up, get to that fan, and you just put a bunch of motor grease, like DC motor grease, not engine motor grease, inside of the little spindle, and then you pop the little magnetic part back on, and it spins perfectly, and then you're like good to go. So it's a very simple process of like repair time capsules, and Airport Extremes are basically time capsules without the hard drive, and therefore they don't really need that fan, because there's like a whole bunch of open air now inside the enclosure. So I was like more or less okay buying used 10-year-old Airport Extreme whenever these things came out from eBay. And I first was like, oh, like if I can buy 4, because there are like lots of 4, and for like $40, then why not? So I try that bidding process. It does not go well. Like I get outbid at the very last moment, as is usual for eBay, while I'm like working and not paying attention to eBay. So yeah, I quickly gave up on that. And then just bought some random, like, not the first offer, but like buy instant one, for a grand total of $40, which sure, I could have bought a brand new access point that's like Wi-Fi 6 and everything, but I don't think those are worth more than like $5 more than the $40 I paid, if that makes any sense. Like this was a much better deal without needing to upgrade everything. So I just got this. It arrived. It was like in mint condition, except for the fact that it arrived open. And this was because it was just wrapped in like the bubbly like packaging that USPS has by default. So it arrived with the bottom like popped out, and I'm like, how on earth did this bottom pop out so cleanly? Because it usually had to get like a spludger and everything. So I was like kind of pleased that it popped out so cleanly. And knowing what the internals of these things look like, because I've repaired a few time capsules before, it looked pristine. So I'm like, whatever, pop the thing back in. I know how to pop it in, no problem. And it works fine. So I had to update the firmware. So it's been a while since this thing was like plugged in and like maintained. It was a few point releases late, and considering the last point release came out like 2 years ago, it's been a while. But I got that upgraded. I got it connected to my network. And that was like step 1, because step 2 was getting it inside of my garage where it can actually connect to everything. So I first had to start with getting internet to the garage, because I didn't want to do like a Wi-Fi to Wi-Fi thing. That always sucks. And it's just gonna make everything else bad, because it's gonna be like extending the same network that is currently pristine and works very well throughout my home, except the driveway. Now I have cable, so we have a coaxial cable that's like coming in from the utility pole in the back of the house. It runs all the way through into my garage, and then via like a nice hole in the eaves, and then it like drops in the garage, just like willy-nilly because the garage is a mess anyways, and then it exits under the door of the garage, and then goes into the door of our kitchen, and then goes like painstakingly nailed along the bottom of the whole house to where the main router is. So it's like this whole kind of rigmarole of like going back and forth, because eventually I wanted to put everything in the garage, but I didn't do that yet. So this has been in that state for like 3 years, and this was not ideal. And what I would now have to do is route an Ethernet back along that same path under the kitchen door, under the garage door, into the garage, and then go into the roof of the garage to go all the way to the front where I would put that airport. I don't know how heat is going to affect this whole thing in the future. So far, so good. So we'll see. But considering I can always buy another one of these, they are plentiful on eBay for not too much money. I'm not too like worried about that. But so I needed to get this Ethernet cable going through that thing. I wanted to maybe not use this route of like going under doors, because that like always gets in the way of our kitchen door, and it's like a huge tripping hazard and stuff like this. So I wanted to punch a hole like directly in the middle of the house where the router was and have this all run underneath, and that for the most part worked fine, because there was already a hole from like past conduit that was cut, like it was not being used for anything, so I ripped the conduit out. I enlarged the hole with a drill bit, and then we had a hole that like went all the way through. You can see the light and everything, so we put some nice caps on that works fine. But we wanted to go ahead and use the hole in the eaves that we made, that the coaxial cable was going through, to put the Ethernet cable. Fun stuff. Coaxial cables are smaller than Ethernet cables, and we only made the hole big enough for coaxial cables. So Ethernet cables would not fit at all. Like it would fit if we chopped it and then redid it. I didn't want to chop it and redo it. So we need to make that hole bigger. So I may or may not have burned my power tool, like drilling through this much wood. So it was a lot. I had to drill from like both ends multiple times trying to like get this going. My like arms and legs are super sore from all this. But I eventually did not give up. I may have broken my power tool, and now have a hole. So this hole goes all the way through. So we now have cables running along the outside of the house, and then they just go up and then through the eaves, and it's much nicer, less tripping hazard. And now we have the coax no longer enters the garage, just drops down from the outside. That's fine. But the Ethernet now goes through, goes along the roof of the garage, and then right in the front, I just basically zip tied the airport to the structure of the house, and that is now there, and it is happy there, and it's probably never moving. Now, that was part one of this. Part two was needing to put the little camera on the outside. So I get up on the roof of my house, and I do not recommend ever going on the roof of your house. It is not safe, and many people have met their end doing this. So do not do it unless you are prepared for that, I guess. Just no easy answer to that. Roofs are dangerous. But I go up on my roof. I am walking very carefully because steep roof with little grainy things, easy to die. So I get up on there. I get the circle view. I didn't want to make a hole right away, so currently I'm lugging a bunch of extension cable to get the thing plugged in. I tried using a little battery. It didn't work, so I was like, fine. I will do this the extension cable way, and extension cables are heavy. So I lugged the extension cable up onto the roof with the little circle thing. I checked it on my phone, and I'm trying to angle it to see is it better here? Is it better down here? We find a place. And it comes time to need to drill a hole back into the garage to have the cable going. Now you don't want to just drill a hole down because water bad. So I want to drill a hole through the wood, but I want to do it at a slight up angle so that way water goes outside, not inside.
Right.
I failed miserably because the first thing I hit was like giant beam, and giant beam be giant. So I made one hole. It was a poor hole. However, Lynn, who was in the garage, was like, I see something. So just go lower. So I went lower, also hit the beam, but just made enough room underneath the beam. So I like readjusted, went the wrong direction. Anyways, I was like, enough holes. Let's just reuse this one. So it's going in the wrong direction. Whatever. Get the USB cable inside because the camera is rated for outdoor, but the power is not. So get the USB cable inside, get that all plugged in. Seems to work fine. So excellent. Now it's time to repatch up the holes. So I get a bunch of caulking and caulk all that as best as I can. So there's now 2 white holes on this like wood finish that we had. So it's like wonderfully hand put together, but maybe waterproof. I don't know. So that's my adventure trying to get a camera to see our street and enough internet to be able to use the camera from the car next to the street. So I'm tired.
So did it work?
Yeah, it does work.
Nice. Okay.
Yeah.
Well, that would be the icing on the cake if it didn't
work.
solve the problem. You're like, all of that work done for nothing.
So there is one problem. The camera's slightly tilted. I do not have the energy or the will to go back on the roof to just slightly twist the camera. So I'm going to have to live with a camera that's slightly tilted because that is the result of my endeavors.
You'll just have to be slightly tilted every time you see the slightly tilted camera.
Exactly. Except it's a rectangle, and the rectangle is like the horizon's like this. So there's no fixing that.
That's awesome.
So yeah, that's my adventure buying a used Airport Extreme because I refuse to buy new access points that are not amazingly better. Like if I'm gonna buy an access point, I want it to have like 10 gigabit Ethernet on one end, or like something better than 1 gigabit because Wi-Fi is technically faster than 1 gigabit now.
Yeah.
So it's like, why have our routers support Wi-Fi 6E, except the uplink to the switch or whatever is a 1 gigabit connection. It's like, no, it needs to be higher than 1 gigabit because you can do more than 1 gigabit on your thing. Otherwise, you're lying and it's like wrong. So yeah, that's what I'm like really waiting for.
Yeah, no, we were talking about this a little, and like I have, a Wi-Fi 6E router or whatever, and it's like my internet speed is like worse than Dimitri's, and I have technically better internet than him. So the Airport Extreme, I'm sure, is just fine for everything that you're doing. And it got me looking at trying to put 10 gig into my local network and everything, and like you said, it's going to require at least a 10 gigabit switch. I have 2 switches technically, so like there's 2, and then in between that is my router, so I'd have to get like a 10 gigabit router too. It's like so I'm looking into it, but it's expensive. It's still not quite at the point where it's like gigabit stuff is dirt cheap now. Not quite at that point, so I'm debating on whether I think it's
$600 here, $600 there quickly adds up when you need 7 of these things.
Yeah, it's bad. So maybe, I don't know, 5 years or so, 4, 3, it'll get a little bit more feasible. But right now I'm like, yeah.
But then we'll have 40 gigabit, and then you'll want 40
dude.
Gigabit. It's the worst.
I know, and I was telling Dimitri, like, the only time that I really even saturate a full gigabit is, like, when I'm transferring files from my MacBook to my NAS for code completion files when we're done. And it's like, it's a once-a-week occurrence, but I'm still like, it'd be really nice. It'd be really nice to have it done 10 times faster, so... Yeah.
Well, think of it this way. If we have 100 gigabit networks, like, in our homes, you don't have to have a laptop with a ton of storage because you can work directly off of that external storage no matter where it is. And that's where I think networking is really going to be very usable, is when we do get these faster speeds, we'll be able to not necessarily need to have a huge SSD in our portable devices. And we can then take advantage of a larger SSD that everything can share. So Yeah, that feature exists now. It's just through fiber, and
Uh-huh.
no one knows what they're doing with that. So that's a whole nother thing fraught with dragons. Anyways, bye everyone.
See ya.